Okay, let's take a look at number 22. We have this premise: the physician ordered 1 gram of aminophylline in 1,000 milliliters of D5W, dextrose 5% in water, is to infuse at 12 micrograms per kilogram per minute per infusion pump. And that's our red flag. Every time we see infusion pump, if we want to find IV rate, it's going to be in milliliters per hour. And let's take a look. The client weighs 110 pounds. Was the correct IV rate in milliliters per hour? Round to the nearest whole number. And that was the correct IV rate in milliliters per hour. It's always milliliters per hour. It's an infusion pump. Okay. So let's take a look. Our infusion rate formula, IV rate formula, reads as our rate divided by medication times volume. The rate has to be per hour, and then the rate and the medication have to have the same units. If it's milligrams up top, it has to be milligrams on bottom. If it's grams up top, it has to be grams on bottom. So we have 12 micrograms per kilogram per minute. And so this is kind of 2 parts, it's kind of 3 parts. If we block out the minute aspect of the setup, we have 12 for every 1 kilogram. We have to measure out 12 micrograms. Okay. For every 1 kilogram that the patient weighs, we have to measure out 12 micrograms. Okay. Well, how much does the patient weigh? How much do I have to measure out? We have to find out how much we're measuring out. The patient weighs 110 pounds. So if we take our 110 pounds, we can't work with this here because we've got pounds, we've got kilograms. That's easy to see coming. So if you want to convert from pounds to kilograms, easy fix. We take our 110, that looks like a 16. We take our 110 pounds. If we want to turn this into kilograms, the easy fix is we divide by 2.2. Every time we go from pounds to kilograms, we divide by 2.2. So we'll take our 110, divide by 2.2, gives us a nice 50 kilograms. So the patient weighs 50 kilograms. So for every 1 kilogram, we measure out 12 micrograms, and the patient weighs 50 kilograms. For every 1 kilogram of patient weight, we give them 12 micrograms. And so if they weigh 50 kilograms, I have to find out how much micrograms of medication I'm giving them. Okay. If you want, you can set up a ratio proportion here, drop your units. And so if the patient weighs 50 kilograms, you've got this beautiful setup. 1 kilogram equals 12 micrograms, 50 kilograms equals X micrograms. You can cross multiply. If you like ratio proportions, this works well here. It always works. If you don't like this, what you could also do is you could take your 50 kilograms, and this has an easy way. Take the 50, multiply it by how much medication they're doing per 1, so 50 times 12. The patient is getting 600 micrograms worth of medication per minute. We never touch this minute here. I mean, we touch the kilograms, we touch the micrograms, but we never touch the minute. So that stays. So the patient's doing 600 micrograms per 1 minute. For every 1 minute that goes by, the patient's getting 600 micrograms. Okay. Looking back at our formula, this rate has to be in per hours. We're still in minutes, and the top units have to match the bottom units. The top units are in micrograms. The bottom units, as given to us, is in grams. Okay. You can convert the micrograms to grams, or you can convert the grams to micrograms. They both work. What we could do here, if we want to go the microgram to milligram way conversion, or I'm sorry, microgram to gram method, we could say a root. Our metric system is grams, kilograms, milligrams, and micrograms. So every time I go to the left, I'm dividing. We're going to the left twice from micrograms to milligrams to grams. So 1 jump, 2 jumps. I'm dividing by 1,002 times. Let's take our 600 micrograms. 600 divided by 1,000 gives us 0.6. So now we have 0.6 milligrams. We only divided 1 time. Take our 0.6, and so now we're at 0.6 milligrams. We need grams. So we're at 0.6 milligrams divided by 1,000 again. We have this ugly number. We could just do the decimal point trick. We have the decimal point trick is for every 0, we move a space. So we have 1, 2, and 3. Let's put our decimal point there. For every space here, we put a 0. So we have 0.0006 grams per 1 minute. And so this question's a little bit lengthier because we're doing this conversion, and then we're from pounds to kilograms, and then from micrograms to grams, and then we still have this minute aspect. So now we're doing 0.0006 grams per 1 minute. We have to turn this to hours. If we rewrite this as 0.0006 grams per 1 minute, and we multiply by 60, the top and bottom by 60 to turn this minutes into hours, we get 0.0006 times 60. That gives us 0.036. So we have 0.036, 1 minute times 60. That's 60 minutes. 60 minutes is really 1 hour. So I could do 0.036 grams per 1 hour. Okay, we're looking really nice here. We've got the 0.036 grams, that's per hour. My formula has to be in per hour, so I've got the per hour. The bottom unit, the medication, we have it in grams, and now our rate is also in grams, so we're looking really nice. Let's plug everything in, and we're good to go. We've got 0.036 grams divided by our medication. We have 1 gram. And multiplying this by our volume reads as 1,000 milliliters. We have 0.036 times 1,000 gives us 36. And that's 36 milliliters per 1 hour. Okay, that's our final answer. I mean, we don't have to do any rounding. It's absolutely excellent. They asked us to round to the nearest whole number, and it came out as a whole number, 36 milliliters per 1 hour. And so our answer here, yeah, it's 36 milliliters per 1 hour. If you stopped here at milligrams, right? And I mean, if you want to stop the video here, that's good. You're fine. You're beautiful. If you stop here at milligrams, we said, hey, take your micrograms, convert it to milligrams. Your milligrams read as, let me bring this piece of paper out. We had 600 micrograms per 1 minute. If you take your 600 micrograms and we convert them to milligrams, that's dividing by 1,000, so 600 divided by 1,000. That's 0.6. So we have 0.6 milligrams per 1 minute. What you could do is this grams down here, this is so easy to see. You're like, oh, this grams, that's also milligrams. So you can do this. You can say, oh, that's 1,000 milligrams. And so now your bottom units, your 1,000 milligrams, match your top units. You don't have to divide this for a second time and have to deal with 0.006 grams. And so that you've got 0.6 milligrams per minute, you can do the same thing. Times 60 on both to turn this into hours. We have 1 minute. We multiply by 60 to get 60 minutes. 60 minutes is 1 hour. Whatever we do to the bottom, we have to do to the top. Excuse me. 0.6 times 60. We get this 36. And this is, although it looks like our final answer, it's not. We have 36 because keeping track of our units, we have 36 milligrams per 1 hour. We still have to plug it into our formula. Our formula reads as rate divided by medication times volume. So we have 36, our rate is in per hour, that's great. And so we said, hey, if I turn my grams into milligrams, I can use this with my top value, my milligrams up here. So if 36 milligrams divided by by the medication, which is milligrams, 1,000 milligrams per 1,000 milliliters. And so if you see this, you're like, oh, it's 1,000 here, 1,000 here, they cancel out. And so you still get the 36 milliliters per hour. And so I had students that did this and they sent me emails about it, and that works too. So our answer is 36 milliliters per hour. And this question was a little bit lengthier because we did several steps of conversions. We went from, and it looks like a lot, but you nailed it. So we went from kilograms to pounds, okay. We didn't do that with previous questions. We went from, we had to find out how much medication we had to measure out, the micrograms. We went from micrograms to grams per minute. We went from minutes to hours. And then finally, once we're here at this beautiful spot, we could plug it into our infusion rate formula, rate over med times volume, and get your final answer of 36 milliliters per hour.